Okay, now members, we are going to see describing a locus. We have seen how we construct angles, how we construct paralleles. We have seen how to describe, how to circumscribe. Now we are going to focus on locus. So how do we describe a locus? A locus of a point, say P, is a path described by P as it moves. So let us see this activity in groups of 5. Get a compass with a sharp pencil. A sharp pencil. Mark out point A, of course on a paper. Adjust the compass so that the distance between the pointer and the pencil, this is the pointer and the pencil is 3 centimeters. Put the pointer at A. Pointer at A. This is pointer at A. And the pencil tip on the paper. Rotate the compass around. Describe the locus made by the pencil tip. So you are going to do it in groups of 5. I'm going to give you, I think that is enough for 6 minutes. Get those papers and then start. I'm going to swap one group, then we use it, then we see what happens here. Okay. Okay. I think those minutes are enough. I'm going to use some for the group C. So this is what the group C are having. The rest you exchange. This is what the group C are having. I hope everyone can see it properly. Group C work. Okay, hope you can see. So group C, this is the diagram they are having, and the description they are having. The locus is a round figure. Okay, let me also try to do the same. Now, for me, this is my pencil, and this is my pointer. So I mark out point A. Let me call this one my point A. This is my point A. Okay. Then I adjust 3 centimeters between this and this 3 centimeters. I measure, this is my ruler. Now may I measure 3 centimeters. Mine, they are going to be there. 3 centimeters. Then from there, they told me put the pointer at A and then move the compass around. So you are going to move it around. So if I move my compass around, it should behave. This is what I'm having. You see my pencil moves around? So this is what I'm creating. So this is my pencil tip. So that's what I've created. Okay. So of course, as the group C, they say the locus is a round figure, as you can see. This is a round figure. So I list, I have the same shape. So you can give them, whoever did this, so this is group C. Group C. So you give one, and then you give 2 marks with each group with such a shape. We give 2 marks for each. So what's the description there? So here we say now it's about the pencil tip. So the pencil tip moves around. Pencil tip moves around. You see, moves around. But as it moves around, you see the path it's creating, making a circular path. A circular path. So that's the first. Now, as it makes the circular path, I want you to note, follow, this is the pencil tip and this is the pointer. You see, any point, the distance here, remember we measured is 3 centimeters. So the distance around any, the distance from the reference point A to the pencil tip is the same, or what we say is equidistant. So, as it moves, comma, the distance between A, and a tip is 3 centimeters, and same throughout. That's the second description. Then lastly, so the pencil tip, what name do we give to this figure? It's a round figure, but there is a common name to this figure. Of course, this would have been our center. So what common name do we give to this figure? Yes, a circle. Okay. So the tip describes a circle. With center what? With the center A. And so that's what I expected. So we can create our friends. This one, if someone wrote just the locus around the figure, okay, we give him or her 1 mark for just making around. So this is what I expect. We have to put in the distance. To make a distance equidistant from this point, it should be 3 centimeters. So this someone should have this friend that. So now, that one pushes us to construction of a locus. Of course, locus has a plural word which we call loci. Loci, this is the plural of locus. Construct a locus of a point equidistant from a fixed point A. Now, the moment we decide they are going to construct a locus of a point equidistant from a fixed point A, I think we can able to see. This locus, the distance from here up to n of this, up to n, what we call the circumference, is equidistant. So the only way we have a locus when the distance is equidistant from a fixed point is when we have a circle. So here, what we do, we just construct, that's what we've been doing. So we construct our circle with is there. So this is the locus. The compass is not missing. It's not in the air. I don't know. It's missing the air. It is not good. Anyway, this is alright. So whenever I tell you to go to get a locus, equidistant, this is how you start from a fixed point A. This locus is going to be equidistant. Construct the locus of a point equidistant from 2 fixed points. Is there any group which tried this? Okay, let me look at it. Okay, so all we had to do, whenever I tell you to construct a locus equidistant, a locus, what should come into your mind is a path. So equidistant to this means that it should be there, but it should be the same. Equidistant means it should be the distance from A to that locus is the same from this to this. Now here we have 2 fixed points. Here we had only 1 point. The only way how you can get a locus when the distance you have that particle is forming, when the locus is formed, when the distance is the same from a fixed point is when we have a circle. So here when we have now 2 fixed points A and B, A and B. So the only locus you can get is when we have a line that's having the distance from here up to here the same as there. So what do you think we are going to do there? What did that group do? We are going to construct a perpendicular bisector. Anyway, so what we do, we put a point, we adjust half midway, you draw an arc up like this. You also draw an arc down. They shouldn't. An arc down. I think we saw this one already. So just apply what we know. Then you don't adjust the same distance. You put here at this point here. Then you draw an arc up and also an arc down like this. So those are the 2 we have. So where they meet, we mark out. So they are meeting here. These 2 these 2. So after that, then you draw. This is going to be our locus here. This is going to be our locus here. So these 2 the distance from here up to here is going to be equidistant. This is going to be our locus. The distance from here up to here is going to be the same. Let us try to measure and see. From here up to here, I'm having 15. Then from here up to here, I'm having 15. So this locus here is going to be equidistant from two fixed points, as simple as that. Okay, let me see the work for group. Let me see, is there a group called 1? No? B? Okay, show me the work for group B on this. To construct a locus of a point equidistant from two intersecting lines. Oh, yeah, where is group B? What did they do? You bisected. So that's all we have to do. We have to just bisect. If they tell you two intersecting lines and then they want a locus equidistant to both lines, you just bisect these two lines. So from here, we put our pointer here. I think remember the ideas of bisecting. You bisect the angle, then you put also here, like that. You can adjust or you can leave. You can adjust here or you can leave, no problem. So you draw another one arc here, then you come here, you draw another arc like that. I think you see where these two are intersecting. This is where they're intersecting. Then you draw. So you draw from here up these points. So this is how we are going to do that. So from here, at that point, so you see the distance from this line to this line is going to be the same, and so this one becomes our locus. As simple as that. So basically, that's what we have. Now we are going to see now how do you relate. I think we start here with relating angles with locus. So that's the numbers. Now we are going to see in the next lesson. Now I want you to go in your activities, in your workbooks, and then you try out exercise. You try out exercises on page 78. You try out that exercise on page 78. So that's it. We are going to see just, and then we conclude our topic. So this one marks the end of our chapter called describing a locus. Called geometric construction skills. You see, we have seen this one. You can apply it in any, or I give some examples about how we can use this. Okay, let us see some examples and then we call it topic.